just for my own purposes, just so I can watch it back and cringe at the sound of my own voice, as we all do. And I am going to go ahead and start the presentation. So welcome to tonight's program, which is called Explorers Wanted Mission to Mars. It's going to last for right around an hour or so, and then we should have a little bit of time there at the end for some questions and some answers. So I like to start out things with a quote that really kind of puts everything into a little bit of perspective for me. And the quote that I chose tonight is a quote that NASA uses a lot in the Mars exploration program. And it's a quote from Leonardo da Vinci. And it says, "When once you have tasted flight, you will forever walk the earth with your eyes turned skyward. For there you have been, and there you will always long to return." And that quote speaks to me on multiple levels. As Patty said, I'm a longtime space exploration enthusiast. And what really kind of sparked that interest for me personally was hearing the personal testimonies of all the different astronauts that have been up into space and looked back upon the Earth. And it's kind of an interesting juxtaposition and comparison that the thing that really got me interested in space is Earth. And thinking about Leonardo da Vinci, those of you that know how to read a calendar and studied your history lessons will know that when Leonardo da Vinci was around, when he was writing and thinking, space travel was not a thing, and neither even was flight. So I love that this really captures that excitement of how traveling into the sky and beyond can really help to put into perspective everything that's happening on the ground. And I think that's very important, especially right now as we all deal with everything that's going on. So a little bit about me. This is the ego section of tonight's presentation. My name is Phil Green, and as Patty mentioned, I am a NASA and JPL Solar System Ambassador, which is a volunteer role. JPL stands for Jet Propulsion Laboratory, and it is the Californian arm of NASA's programs. It's owned and operated by Caltech, which is a university over in California. And one of my favorite little tidbits of information is that that whole arm of NASA was invented when two Caltech students almost blew up their dorm room with experimenting with trying to create jet fuel. And so NASA decided, well, maybe they should sponsor something out there to prevent that from happening anymore. Some of you may have seen me around as well. Those of you who are residents of the Village of Woodridge, I work for the Village of Woodridge. I am the village planner, which if you're not quite sure what that is, I am responsible for things like zoning questions, business attraction, business retention, and I do a lot of public outreach activities too. So hopefully you've all filled out your 2020 census by now, because that's one of the big things that I'm personally responsible for, is making sure you all do that. And I know George from the library is on our call tonight, and he's been a phenomenal help and part of our team in making sure that happens. So that's one of the things I do. And if any of you were around for Restaurant Week last year, that was one of my projects as well. So a lot of things in terms of just the day-to-day running of the village, that kind of falls under my remit. And for those of you who are able to detect the accent, I was born and raised just outside of Liverpool in England. I have been living in the state, specifically in the Illinois area, for about 2.5 years at this point. But as you can see behind me, I am beaming to you live from the planet Mars right now. And if my shoulder disappears from time to time, that's definitely because of signal interference and nothing at all to do with the fact that I'm actually in my spare bedroom and that's a Zoom digital background. It's definitely satellite interference. So I think Patty gave it a phenomenal introduction, but I did kind of want to just go over what it means to be a solar system ambassador really quickly. As was mentioned, I did not know this was a thing up until last year when I attended a program at the library back when we were able to do in-person events. And I heard the ambassador, Mark Benson, speaking, and I was like, wow, I could totally do that, I think. So it is a volunteer program for space enthusiasts, and there's over 1,000 of us all over the country. And people come from all areas of expertise and all walks of life. So I'm going to preface tonight with saying I am not a scientist. I'm not, completely familiar with every single piece of planetary science and space science. And if somebody came to me and told me to get a rocket up into the atmosphere, we'd all be kind of doomed, no doubt. But my area of expertise, if you will, is talking. Everything I've ever done career-wise has been about speaking to people. Before I was an urban planner, I was a teacher. So I've always been pretty good at taking complicated ideas and making them hopefully easy for everybody to understand. And that's what being a solar system ambassador is all about. So we get trained directly by NASA. So we speak to astronauts, we speak to scientists, we have formal training like at least twice a month on all kinds of different things. And then we go out there and we deliver programs just like we are tonight to people in our communities and try and get everybody really excited about the amazing things that NASA is doing. It definitely comes with perks. I have a cool little name badge right here that actually has our Mars 2020 rover on it. But it's a complete volunteer program. So that's just kind of a quick overview of everything involved. And I'm going to stop talking about myself and start talking about Mars, which is what we've all come to see tonight. So I've spoken a lot about me, but what I want to do now is ask you guys about you. So I'm sure it's 2020. We've all had, I'm sure, a fair number of Zoom calls. I'm sure this isn't everybody's first time in Zoom, but if it is, we're going to make it real easy. I'm going to go ahead and launch a poll, and it's going to just create a few questions up on the screen there in front of you. And I'm going to ask you all just to answer them as honestly as you can. So our first question is, what brought you here today? I want to know whether or not you were just bored on a Tuesday night and didn't know what else to do, or whether perhaps you are super passionate about space and space exploration. So you should have a question up on your screen. If you don't, let me know. But go ahead and click the button that is of most reference to yourself. It looks like it's actually launched all of the questions there for you. It's going to take you through all of them. So our questions are, what brought you here tonight? What is your level of space knowledge? And finally, the big one, would you take a one-way ticket to Mars? Would you up and leave the Earth and head out to Mars, never come back? I'm going to give us all a couple minutes to fill those out. Alrighty, we still got a couple people just finishing filling them out, and once we're done there, I'll run through the results and we'll see what kind of group we've got tonight. Alrighty, looks like we've got everybody who we're going to get. So what brought you here today? Looks like 43% of us are super passionate about space and exploration. 29% of us are kind of interested, but Mars seems pretty cool. 29% of us, again, have heard a little bit about this new Mars mission and wanted to know more. And one person just needed something to do on a Tuesday night, and I admire your honesty. Question 2, your level of space knowledge. We have 3 geniuses who could probably launch a rocket single-handedly. I'll actually be handing the presentation off to them because they probably know more than me. most of us, more than half of us, are super interested and they'll watch big launches and documentaries. I'll say that's me. I really fall into that part of the category. Like I say, I'm not somebody who could launch a rocket single-handedly, but I'm definitely somebody who will absorb a ton of different space science and launches and documentaries and things of that nature. About a third of us are really interested, but haven't read too much up on it. And one person, also super honest, is totally new to this. And we have a really interesting split for question number 3, about half and half. So slightly less than half of us are ready to make the move over to Mars, and the rest of us are quite happy to watch from Earth. And again, that's kind of me. There is a whole generation of people getting ready to boldly go, and I will be boldly supporting them from the comfort of home, because I think I still have plenty of Earth left to see before I'm quite ready to leave it. So, all right, well, with that said, let's take a little look at what we're going to be doing tonight. So, our mission for tonight, explorers, is as follows. We're going to explore the surface of our closest solar neighbor, and together we are going to create the first human colony on Mars. That animation took me 2 hours, so if the rest of tonight's presentation is no good, that's why. That took 2 hours to make that little man fly up there, and I think you can all agree, totally worth it. So, before we actually start our mission, we need a set of mission objectives. We need to know what we're trying to achieve tonight. So, objective 1 is to train for our mission. And we're breaking that down into 2 different parts. Before we can get to Mars, we need to know where it is. And philosophically, we need to know a little bit more about why we're so interested in going. And we want to know what we already know before we get there. So we need to know where we're going, we need to know why we want to go there, and we need to know our background knowledge. We need to know what we know before we go. Then we need to get ready for our launch. So we need to know a little bit more about what missions we already have on the surface of Mars. So who's been there before us, who's going to be ready to meet us when we get there. And then finally, we're going to lift off on our mission tonight, which is to know a little bit more about Perseverance, which is our 2020 NASA mission to Mars, which is set to launch at the moment on July 30th. And I say at the moment, and we'll get a little bit more into why that might change as we go through this tonight. And we need to answer that big question of, if we're thinking that tonight we want to set up the first ever human colony on Mars, we need to know a little bit about how possible that really is, and whether there really will ever be humans on the surface of the planet Mars. So, let's start with our training. What do we need to know before we go? Well, we need to know a little bit about where we are going. So this is us right here on Earth, our big blue marble floating through the solar system. And Mars is our closest neighbor. It's the 4th planet away from the sun. So on average, we're about 93 million miles from the sun, which even though in the middle of summer and how hot it's been lately, it definitely feels like we're a lot closer than that. Mars is a little bit further away, so it's about 142 million miles away from the sun. And that has a big impact on temperature on Mars. Mars can get very, very cold. Mars is a lot smaller than Earth too. So we're about 7,926 miles all the way around our big marble, and Mars is smaller. It's about 4,200 miles around. And we'll look a little bit more into detail on that in a little while there. Go back real quick. So next, what I'm going to show you guys is a quick 2-minute video that just goes into a little bit more detail about Mars's positioning in the solar system compared to ours.
The Opposition of Mars, presented by Science at NASA. By the time you finish watching this video, you'll be about 1,000 kilometers closer to the planet Mars. Earth and Mars are converging for a close encounter. As March gives way to April, the distance between the 2 planets is shrinking by about 300 kilometers every minute. When the convergence ends in mid-April, the gulf between Earth and Mars will have narrowed to only 92 million kilometers, a small number on the vast scale of the solar system. Astronomers call this event an opposition of Mars, because Mars and the Sun are on opposite sides of the sky. Mars rises in the east at sunset and soars almost overhead at midnight, shining burnt orange, almost 10 times brighter than a first magnitude star. Oppositions of Mars happen every 26 months. Of a similar encounter in the 19th century, astronomer Percival Lowell wrote that Mars blazes forth against the dark background of space with a splendor that outshines Sirius and rivals the giant Jupiter himself. In other words, it's really easy to see. There are 2 dates of special significance. April 8th is the date of opposition when Mars, Earth, and the Sun are arranged in nearly a straight line. If the orbits of Mars and Earth were perfectly circular, April 8th would also be the date of closest approach. However, planetary orbits are elliptical, that is, slightly egg-shaped, so the actual date of closest approach doesn't come until almost a week later. On April 14th, Earth and Mars are at their minimum distance, 92 million kilometers, a 10-month flight for NASA's latest Mars mission. You won't have any trouble finding Mars on this night. The full moon will be gliding by the red planet in the constellation Virgo, providing a can't-miss landmark in the midnight sky. Although these dates are special, any clear night in April is a good time to look. Mars will be easy to see with the unaided eye, even from brightly lit cities. With a modest backyard telescope, you can view the rusty disk of Mars, as well as the planet's evaporating north polar cap, which has been tipped toward the Sun since Martian summer began in February. Experienced astrophotographers using state-of-the-art digital cameras can tease out even more. For example, dust storms, orographic clouds over Martian volcanoes, and icy fogs in the Great Hellas Impact Basin. The view has been described by some observers as Hubble-esque. Update: you're now 1,000 kilometers closer to Mars. Enjoy the show! For more news about things bright and beautiful.
Alrighty, so as some of you may have noticed, that video was from 2014. So it's not actually happening in April in 2020. Our opposition window in 2020 sits kind of somewhere from July through to the end of August. So it's happening pretty much right now and should start to get a lot closer over the next week or so. One of my favorite things about that particular video, all those incredible images that you saw there towards the very end of I think the video describes it as something like, professional astrophotographers using state-of-the-art digital cameras. That really undersells everything that goes into creating images like that. I mean, the equipment that these people have is insane and costs thousands upon thousands of dollars. And if you take your, I don't know if this is going to disappear into my background or not, but if you take your typical cell phone camera, I have a Samsung that has something like a 12 megapixel camera. I'm talking these state-of-the-art digital cameras have something like 18 million pixels. So it takes a lot of energy and a lot of time to get a good photograph of Mars being so far away. So opposition is when Mars and the Sun are on directly opposite sides. So you got Earth there in the middle, Mars on one side of us, Earth on the other. And that means we're as close as we possibly can be to our nearest neighbor. We're not on opposite sides of the Sun. We're not having to fly around the Sun to get there. And that gives us our best opportunity to land there. It happens about once every 26 months. So just over once every 2 years is really our only opportunity to go ahead and land something there on Mars. And obviously there's a lot more considerations to be made on that. As with any launch, I don't know if anybody watched the recent launch from a SpaceX rocket to get 2 astronauts up to the International Space Station. It was originally scheduled for May 27th, ended up going up, I believe, on the 30th. That happened because of something as simple as a little bit of wind speed, some cloud cover, things like that. So there are so many different factors that we have to get right when we're picking a launch date. And if we were to launch on July 20th, which was the original scheduled date for our Mars 2020 rover to launch, it would take us around 213 days to reach Mars. And that changes a lot over time. And I'll give you guys a little bit more information on our launch when we get ready for that part of our mission tonight. So question 2, was, why are we so interested in Mars? And I think that's probably the biggest question, right? Why do we care so much about this dusty red rock in the sky? Well, so NASA has a whole team, a whole program dedicated just to Mars, and it is a science-driven, technology-enabled study of Mars as a planetary system, and these are the specific science goals that that mission has. The formation and the early evolution of Mars as a planet, then the history of geological and climate processes that have shaped Mars through time, the potential for Mars to have ever hosted life, which is otherwise known as its biological potential, the future exploration of Mars by humans, and how Mars compares to and contrasts with Earth. Those are all the official goals of the Mars exploration program, word for word. But what I've done is I've boiled that down a little bit into a pretty easy to understand acronym: MARS. Motivation, access, resources, and similarity. That's why we're so interested in Mars: motivation, access, resources, and similarity. For a little bit more detail, what's our motivation? It demonstrates our political and economic leadership as a nation, us being the United States of America, and it expands the US leadership in the peaceful realm of space. Everything about space exploration is super political, and there are so many great books. One of my favorites that I was just getting through was a book called American Moonshot, and it talks about the 1960s moon landings, and specifically from the point of view of President John F. Kennedy, and just how intent he was on making that happen, because he knew it would send such a powerful message to the country that was just coming through a huge world war and a Cold War with Russia. Space itself is supposed to be peaceful, and it's supposed to be a realm of cooperation and friendliness between different countries. And so we really want to, as a country, be leading that and be making allies through space. And as a country, it unites us in pursuit of a common goal. We're all very excited about space exploration. It's something that is somehow at the same time both easy to understand and impossible to comprehend. So it really does get everybody talking, just like all of you here tonight have decided to join us, because it's something that we all find super interesting and cool. When it comes to access, as we kind of just discussed, Mars is our closest solar neighbor. That opposition occurs once every 26 months. So every 2 years, we get a really good opportunity to send something over to the planet Mars. Resources. Now, this one's really interesting. Mars has soil that contains potentially extractable water. So that means that, feasibly speaking, we could very well end up in a situation where we are able to sustain human life on Mars. And like we say, that's our goal tonight, is to establish our first ever human colony on the planet Mars. Mars gets enough sunlight, even though it's far away from the sun compared to Earth. It's not so far away that it can't generate some solar energy. And we'll talk a little bit tonight about what use we've made of that already. It has some atmosphere. Now, what I mean by that is, it has some air pressure. It has some gravity. It doesn't have quite as much as the planet Earth does. So if anybody has seen the movie The Martian, starring Matt Damon, great movie, mostly very scientifically accurate, but one thing that they don't quite get right is the very opening scene that has a huge dust storm that blows over their solar panels and knocks down their rocket that's trying to take them home. That wouldn't happen. There is not enough wind power to knock over a rocket on Mars. And that creates some challenges for some of our missions. And actually, my favorite thing about our Mars 2020 mission is directly impacted by that lack of air pressure and gravity. So stay tuned, and we'll talk about that as the thing I'm most excited about. And it does have carbon dioxide, which those of you who remember your entry-level biology and chemistry and everything else, all your entry-level sciences, carbon dioxide is what we breathe out. We cannot breathe it in, but that is potentially a good thing. We are looking into various ways to convert carbon dioxide into oxygen, which we know our trees do for us on Earth right now. So we're looking into ways we can make that happen on Mars, understanding that we don't actually have trees out there quite yet. And finally, similarity. Mars is very, very similar to Earth. It has hills and valleys just like we do. There's topography, as we call it in the urban planning world, right? There's different levels, different heights. There's ridges and mountains and valleys and all kinds of things. So it's very similar to us. And it has a very similar history of climate change. Maybe. So everyone knows, I'm sure we've all had conversations about the impacts of climate change onto planet Earth. And we think, you know, and let's talk now real quick about what science is. Science is just a theory, okay? And science starts from the position that we could be wrong. And if you're entering something and saying, I'm right and I know I'm right and I'm going to prove I'm right, you're not doing science. If you enter something and say, I have no idea what this is, so I'm going to find out, now you're doing science. So by entering with this idea that we have no idea and figuring it out, we've started to believe that there's a very big potential that Mars once looked and functioned very, very similarly to the planet Earth, but went through a very similar process of climate change and loss of atmosphere that's resulted in that big red dried up planet that we know and love today. And the next thing I'm going to show you guys is a really short animation where we've taken digital imagery of Mars from all the various satellites we have up there, our rovers, our landers, and everything we've ever done with the planet. And then NASA's run it through an artist rendition and various computer simulations to take an idea of what Mars might once have looked like when it was a wet planet like Earth is today. So this is Mars that's on the screen right now in front of you. And taking into account the previous signs that we found of, you know, the ice that we found before and the potentially moist water that's been found in the moist soil before, and then looking at those hills and those valleys that we've spoken about, this is about as close as we've come to being able to map out what Mars may have looked like many, many years ago. And so this is Mars from potentially millions of years ago. And this is Mars today. This is our big red floating rock. And one thing that I found really interesting when I was kind of doing a little bit of studying up before, you know, putting this presentation together for us all tonight. If you were to take Mars as it is right now, just completely dry and cut it all up, the land available on Mars is about the same as the land that is currently accessible on Earth. So you could chop up Mars and lay it perfectly over all the different countries of Earth. Where we get all our additional size, it's all our oceans and seas. So potentially, you know, depending on how we do in responding to the threat of climate change, and that's something that NASA is superb on, by the way. One of my favorite, most interesting parts of NASA science is the different Earth observation platforms they have and all the different data they make available to us to track how we're doing in that fight. That is potentially a window to our future. So not the best news, but good that we know it and we can study Mars and find out a little bit more about potentially what went wrong there and stop it from ever happening for us. All right, I'm gonna go ahead and switch up my screen share real quick and take us over to this Mars Quick Fact Guide, again, handily produced by NASA, and you can find out more at mars.nasa.gov. That takes you to the entire webpage for Mars that NASA runs and operates. And this is just a really handy infographic that I wanted to scroll through real quick that really helps to put a lot of things into perspective. So looking at the size of Mars compared to Earth, it's about half as wide and about twice as wide as our moon. And that is going to be very good to know later on, because our moon does come into the conversation as we go later. And there, kind of like I said, is a little representation of, if we chopped up all the land on Mars, we could actually fill up all the countries on Earth and still have our oceans and seas in the exact same way that we do right now. Mass, those of you that remember grade school physics might remember the difference between mass and weight. Your mass stays the same. Your weight is impacted by gravity. But the mass of Mars, the complete size of it, how much Mars there is, there's about 1/10 of what there is of Earth total. Volume is the amount of space occupied, and Mars is about 15% of Earth. So you'd need 6 Marses to fill 1 Earth in this kind of Pac-Man style rendering that they have right there. Density, we don't really need to go into. Structure is kind of super interesting because, like I was saying before with science, it's, you know, a great way to say we don't know things. We don't know what the inside of Mars is like, and future missions hope to find that out, but we really don't know what the inside of Mars really looks like. So we know that Earth has that hard crust, which is what we live on, which is what we're on right now. And then there's the mantle, and then there's the liquid outer core, so all that lava bubbling up underneath. And then the solid inner core, that big old ball of metal that we know to be inside the middle of the Earth. We don't know what it could be like in Mars. It could be extremely similar. It could be totally different. One of our rovers, Curiosity, which we'll talk about momentarily, is doing some digging, but digging on Mars is hard. It is very difficult to dig down to that depth. So as we start to develop more and send more technology up there, that's definitely a future focus for us up there. Distance, we've kind of gone over. Here's kind of 2 of my favorite things about the differences between Earth and Mars. So 1 year on Earth is about 365 days. On Mars, it's about 687 days, which means they have seasons just like we do, but kind of like in Game of Thrones, remember when that was a thing? The seasons are a lot longer. So, you know, ours are kind of quartered up quite neatly there. But on Mars, spring lasts almost 6 months. Summer, the same thing. Autumn, the same, and 6 months long winters. So very, very long seasons over there. But the day is only slightly longer. So when we're planning out our Mars missions, we don't think in terms of Earth days. We think in terms of what we call sols. So how long it takes to move around the sun. Sol obviously being a Latin word for sun, S-O-L. And so we have to think in terms of that Mars time. You know, when I first moved to the States, it was difficult sometimes for me to get my head around living in a different time zone and constantly having to think that all my friends back home were 6 hours ahead of me. So maybe I was being somewhat obnoxious in messaging them when they were asleep. Now think about having to do it with an entire different structure of a day going on a different planet when you're trying to send instructions over to your rover that's over there on Mars. So that brings us to the end of our section 1 of what do we know about Mars. And now we're ready to prepare for launch. So this up here is Curiosity. This is our big rover that's on the surface of Mars right now. And we'll meet Curiosity a little bit later. But for now, I want to show you guys another video. It's about 4 minutes long. And it gives us a really good overview of our history with the planet Mars. Humans have been going to Mars now for almost 50 years, which is an insane amount of time. To think of the fact that we have had the ability to send rovers, landers, and satellites, and we'll talk a little bit about the difference between those. That we've been able to do that since the 1970s is pretty impressive. And if we were able to land things on there 50 years ago, just imagine what we're able to do now. So I'm going to go ahead and play the video.
Hey, there we go.
There she goes. That's data.
There is some sort of a pattern to the data, and we
extraordinary men and women of NASA and our Jet Propulsion Laboratory. Right now, the wheels of curiosity have begun to blaze the trail for human footprints on Mars.
Well, today on Mars, history was made on Earth. The successful landing of Curiosity will stand as an American point of pride far into the future.
I just wanted to call and say congratulations to the entire Mars Science Laboratory team and really all of JPL. You guys should be remarkably proud.
All right. Well, I think that gave a little bit of a spoiler for whether or not we think we're going to be able to get humans up into Mars. But that's okay. You know, that's what we're here for tonight. So there's a few things that I kind of really adore about that video. And one of them is just seeing that progression over time of all the different technologies we've learned how to get there and get there better. So you see the evolving from parachutes, which that's one of the things that lack of atmosphere really makes so much harder. Is it's harder to deploy a parachute because how does a parachute work? It catches air pressure that's trying to lift it up. That's difficult when there isn't really that much air pressure up there. So then we evolved into those big bouncy ball landers, which I don't know about you guys, but sign me up. If I'm going to Mars, that's how I want to land, is to bounce and roll for a little bit. And then finally, as we got more and more advanced, we were able to really kind of, get a grasp of what it takes to utilize jet propulsion and slow our descent down almost as if we were flying, right? And really nail those landings. And the landing technology on our Mars 2020 rover Perseverance is next level. And I'll tell you guys all about it when we're up to that point. So the graphic that's on the screen right now is just an overview of all the different Mars-related projects that have been sent up over there since the year 2001. So as we saw, we've been sending missions to Mars since the early 70s. And a little bit before that for satellites. But this is everything that's been up there since 2001. If it's in blue on your screen, that is a NASA mission. That is a US mission. If it is in orange, that means that it is an international mission. And again, it goes back to what we were talking about before. Space is a place of cooperation and friendliness and countries supporting each other. And that is so vitally important. So the letters ESA stand for European Space Agency, and that's multiple different European countries working together. They're headquartered out of Germany. They've got a fascinating scientist that works for them who every launch that he attends in a different Hawaiian shirt for good luck. RSA is the Russian cosmonauts. UAE is the United Arab Emirates. They're actually scheduled to launch something this year. And the Chinese orbiter, lander, and rover are also scheduled for later on this year. So really a great, fascinating time to be getting up there. And we're going to go a little bit more in depth on a few of these different previous missions that we've sent up there to Mars. So we're going to start with Spirit and Opportunity. So these are twin rovers that landed on the surface of Mars in 2004. And their original mission was 90 days long. That was the plan. We were going to send these twin rovers up there for 90 days. And as you can see, Spirit lasted for 6 years. Opportunity lasted for over 14 years, almost 15. and drove the most miles on the planet. They drove 28 miles. So this was really quite a big step up in technology. Spirit and Opportunity were really our kind of putting our money where our mouth is when it comes to Mars. So the previous rover that we'd sent up there before, the Sojourner rover, was roughly the size of your standard microwave. Spirit and Opportunity were more like a golf cart. They were big rovers designed to put in work and take photos. You can see we took somewhere nearly 400,000 photos between the two of them to climb slopes, 30-degree gradient on there, and to drive around. So both of the Spirit and Opportunity rovers were geologists, which if you don't know what a geologist is, it's a scientist who specifies and really specializes in studying rocks, okay? So they would pick up different samples of rocks and they would go ahead and they would analyze them and try and find out what the rock was made of, how long it's been there, whether or not it could have ever sustained any microbial life. And microbial life just means very small individual microbes, so very, very tiny, invisible to the naked eye life. We're not talking little green men, Martians, Mars attacks, anything like that. We're not looking for aliens. We're just looking for signs of whether anything that could have once been life or whether anything that could evolve into life exists on the planet Mars. Our next rover that we're going to take a look at is Curiosity. So if Spirit and Opportunity were the size of golf carts, Curiosity is a whole car. It's the sedan that I drive to work every single day. And Curiosity actually had a slightly different name when it was being considered. Curiosity was the Mars Exploration Laboratory. Curiosity is a science lab on wheels. So Curiosity landed in a place on Mars called the Gale Crater, which we'll look at that in a moment. And it acquires rock, soil, and air samples for onboard analysis. So it is a drivable lab driving around the surface of Mars and picking up readings and analyzing them and sending those results back to Earth. We aren't sending the actual rock or the actual soil back home. We're actually reading it all on board the rover and sending back the results of the findings. I can say the car-sized rover is about, I love this, is about as tall as a basketball player. How tall is a basketball player? I don't know, 7 feet maybe? Is there a specific basketball player they're trying to reference? I don't know. And then it has about a 7-foot long arm to place the various tools that it carries close to rocks selected for study. And that big size allows it to carry an advanced kit of 10 science instruments. And if you think that's impressive, just you wait till we take a look at our 2020 rover. And then we're going to watch a quick video now on Curiosity. So this video is taken from Curiosity's 5-year anniversary. It's been there a little bit longer than that now, but it provides a really good overview of everything that Curiosity has achieved so far. Including these tools, the 17 cameras. I love this, a laser to vaporize and study. I always get my little Dr. Evil, a laser, to vaporize and study small pinpoint spots of rocks at a distance, and a drill, as we mentioned before, to collect some powdered rock samples. We're going to go ahead and whack a video on now. It's just a couple minutes long. Alrighty, so that kind of showed you a little bit about what we were talking about before, about how we are learning so much about the fact that Mars may have once looked very, very similar to the planet Earth, with rivers and ravines and lakes, and was habitable up until the atmosphere started to go away, exposed it to more radiation from the sun, and dried it up and made it the dusty rock that we know today. So I am going to go ahead and switch my screen real quick to something pretty cool. We are actually going to go to the surface of Mars for a little bit, and we are going to take a look at our next robot up today, which is InSight. So I mentioned before that there are 3 different types of Mars mission. We have our satellites, which never land. They just orbit around the planet, taking pictures, sending signals, all these kind of things. We have our rovers, which rove. They have wheels, they drive, they move around, and they explore. And then we have our landers, which is what InSight, which landed in 2016, is. InSight is a lander, which means it lands on the planet's surface and it stays where it is. It lands somewhere we've pre-selected as somewhere that we're very interested in, and it stays where it is and it performs different science experiments. And I'm actually going to show you a little bit about how it does that. So over here you can see InSight. Down here we have the views from 2 of its different cameras. We'll go over what they are as we go through this. So the first thing that the lander does when it lands is it needs power. So this is really interesting because InSight uses solar panels, which we've already mentioned. Mars is close enough to the sun to be able to get power from it, right? Our new rover doesn't use solar panels at all. Why not? Because solar panels can get dusty, and when they get dusty, they can stop working. Our new rover actually has a nuclear generator built into it. So it's using plutonium to stay powered as it drives around. But InSight didn't quite have that technology in 2016. It uses these 2 big, beautiful peacock tail style solar panels, and they are about 20 feet from point to point. Next is what is our ICC camera. That's this little guy right here, instrument context camera. So what this means is it's how we can view our table that InSight's working on, which is our instrument deployment arm, which is this guy right here. Now, one of the questions that I'm sure some of our younger folks probably have is, how do you drive a rover? We're not sending people up there. How do you control this? And actually, our rover drivers and our machine operators have incredibly varied backgrounds. One of them, just kind of came, I believe, from like an English and classics background and now controls these rovers. So what they do is they actually send a set of instructions up a few days in advance, right? So we kind of know from viewing these camera feeds how everything's going, and we plan out our moves in advance as to what everything is going to do. And there's a couple of really great games on the NASA website that I'll give everybody links to at the end that talk you through exactly how that works. It's very, very interesting. But another thing, and something that the Matt Damon movie The Martian got very, very right, is that we keep models of all of these here on Earth, so that if ever anything goes wrong or we need to see how our rover or our lander would respond to something, we keep that capability to be able to work through problems. And then we also spend the first few days of anything that lands. So I believe our Mars 2020 rover is scheduled for 16 sols of practice of just limbering up and stretching. So when InSight landed, this arm, as we kind of saw it stretch out, it would actually do this quite a few times just to make sure everything's functioning correctly, nothing broke on landing, and that we can go ahead and do things like go ahead and drop this seismometer, which, for those of you that don't know, a seismometer measures for earthquakes. So one of the things that InSight is doing is dropping this little tool down. You can see it would see right there whether or not it had dropped it successfully. It would do that to make sure and measure any earthquake activity on Mars. And then because of the big changes that we can experience in temperature and in dust, it puts this shield on top of it. I'll drop the link to this website for you guys at the end. Play around with it. It's a very, very cool tool. But for now, we're going to go ahead and we are going to go back to our presentation. So we have studied hard. We know where we're going. We know how we're going to get there. We know how long it's going to take us to get there. And we know all the different robots that are there for us when we get there. Now's the time to take a close look at our Mars 2020 mission. And we're going to start off with a quick video that explains a little bit more about it.
We are a species of explorers, believers.
We choose to go to the moon in this decade and do the other thing. Not because they are easy, but because they are hard.
We are willing to do the hard things, to overcome the many challenges. This is what brings out the best in us.
We go for a mission to the moon.
Our path has led to success and to bitter losses.
We come together today to mourn the loss of 7 brave Americans.
Yet, even when faced with tragedy and setbacks, we persevere. We keep striving. We keep believing. From space, we see our planet as a whole. We see the challenges facing it, and we face those challenges together. We will not give up. We challenge convention. We refuse to accept the status quo. The time at hand is hard, but we will persevere. We can still draw hope from the moon and the stars, from space, from exploration. There is a new day beyond the challenges we face now.
Curiosity, insight, spirit, opportunity. If you think about it, all of these names of past Mars rovers are qualities we possess as humans.
10, 9, we have ignition sequence start.
But if rovers are to be the qualities of us as a race, we missed the most important thing.
3, 2,
perseverance.
launch commit, liftoff. We have liftoff.
We are a species of explorers. We will meet many obstacles on our way to Mars. But as humans, will not give up. We will always persevere.
That video never fails to give me goosebumps. I was so excited to find it. They only released that video maybe a week ago, and I was already pretty much done with putting together our program for tonight, and I just knew I had to include it because I think it speaks a lot to 2020 and the year we've all had, right? You know, everything's been a little bit different this year. And if there's one thing that we can say in favor of the human species, it's that we persevere and we find new ways to keep going. And I think it's a brilliant name for this project and very inspiring. So let's talk a little bit about what it is and why we should be so excited about it. So there it is right there on your screen right now. That was taken just last week. It's been loaded into its fairing. A fairing is a protective covering that helps the rocket to move through the air while keeping the important pieces covered and protected from the elements and the G-forces and the extreme temperature and everything else a rocket goes through when it's leaving the planet. And it's headed on its way to Florida, which I don't know about you guys, but I don't particularly envy it right now. I don't think I'd want to go to Florida right now. But it's headed there, and that's where it's going to leave from. It's going to leave from Cape Canaveral, which is also where we sent off our SpaceX mission just last month to send our 2 astronauts up to the space station. And it's traveling on an Atlas V rocket, which is the same rocket that we've used to send 11 different missions to Mars. So we know that rocket works. So that's what the tip of that rocket's going to look like. That is the Mars 2020 logo that you can see right there beneath the NASA meatball. And let's look into a little bit more detail about what is actually happening with that rover. So the overall mission name is Mars 2020, and the rover's name is Perseverance. The main job of the Perseverance rover is to seek signs of ancient life and collect rock and soil samples for possible return to Earth. You'll notice there's a couple of very specific words in there that are kind of important. We are looking for ancient life. We're still not looking for little green men that are still running around Mars. We are looking for things that may have once existed. We're looking to prove that life did exist on Mars once upon a time. And we're collecting rock and soil samples. Now, you'll remember that Curiosity processed everything on board, and Perseverance will do that to an extent as well. But remember what I said before about how important it is that different countries work together in space? Well, NASA is actually working with the European Space Agency, my folks from back home, to develop a mission to actually bring back some of this rock and soil samples. And that's so important because one really cool thing, think about the moon. And we went to the moon in 1969. That's 51 years ago, right? And when we went to the moon, we collected a bunch of samples and we locked some of them away because NASA had the foresight to know that our technology was only going to get better with time. So we kept some of those samples locked away so we could process them back on Earth as our technology improved. And that's one of the goals of Perseverance, is to be able to actually bring some of Mars back to Earth for us to look at. And I could spend a whole entire other presentation talking about what we call planetary defense, which sounds like shooting asteroids out of the sky with lasers, and kind of partially is. But that's all about, they have these whole teams dedicated to making sure we aren't bringing back anything that's going to, you know, infect humans, or we're also not sending anything out to Mars that may create life accidentally, right? That could be a whole other talk. Our launch window currently sits between July 30th and August 15th, 2020. There are so many different variables that really kind of decide what we're going to do and when we're going to launch. Again, weather is a huge thing, but one really difficult thing to try and plan for is, as we kind of looked, and I'll show you this in a minute, we have a lot of different satellites floating over the top of Mars. One of the things that we try and do is time our launches so that when we're landing our rover, those satellites are all lined up over our landing spot. So that way we're able to keep constant communication with our rover. We're launching from Florida, as mentioned. The landing, no matter when we launch, we know that we're landing on February 18, 2021. So keep that date in your calendars. I'm sensitive at the time, so I'm going to try and get through this bit as quickly as we can. We are landing in a place called a Jezero crater on Mars, which is a place that we think is not what we call a special site, meaning we don't think there's any life active there right now, but we do think it's somewhere that has a very high probability of at least once containing life. Our mission duration, the rover is planned to work for at least 1 Mars year, which is about 2 Earth years. But as we've seen from every rover we've sent before, sometimes they last a lot longer than that. And this is the bit I'm most excited about. It's carrying with it a tech demo. It is carrying a helicopter. It is carrying a tiny little drone. I say tiny, it's not that small, but relatively speaking, compared to the size of the rover, which is about the size of a car again, it's carrying a helicopter. We're going to fly on another planet for the first time ever. And that is phenomenal because we keep saying things are very different on Mars. It's not as easy to fly when you don't have all the gravity bringing you down and the air pressure pushing you up and finding that balance. It's a much more difficult experience. So the fact that we're actually going to go ahead and try it is outstanding. I am going to quickly, like I say, I'm not a scientist, I'm just a talker, so I know enough about this to be dangerous, so I'm going to give you guys some overviews on this real quick. But some of the most exciting things that are loaded up on Perseverance, there are over 23 cameras over on this rover. So we're going to have the most incredible views of the planet Mars like we've never had before. a weather station. Actually, one of my fellow solar system ambassadors, he is, like I say, if I'm not a science guy, he is the science guy. He actually runs an entire software program that he created himself that gives us weather reports from Mars. So he's going to be very excited for the data coming from Perseverance. The thing that I'm really excited about is MOXIE. And MOXIE is one of our test experiments. So we're not actually going to really achieve anything with MOXIE beyond seeing if it actually works. You know, we're not putting it up there to do something. We're putting it up there to see if it can. But MOXIE, as we said before, MOXIE is our artificial tree. So MOXIE is taking the Martian carbon dioxide and turning it into oxygen, which has very, very big impacts on whether or not we'll ever be able to send humans up to the surface of Mars. So there are 7 key things that if you're going to remember anything about Perseverance, there are 7 key things I want you to remember from tonight. So the Perseverance rover embodies the NASA and American and human spirit of overcoming challenges. It would have been really easy to cancel this project when everything got really bad with the COVID problem, but we didn't. And we could have tried again in 2 years, but we're not. We're still doing it because it is so important to our spirits as a human species to prove that we can do these things. It builds on the lessons of other Mars rovers. So as we've already said, there are so many other rovers that have gone up there and we've learned so much about the best ways to control them. And, you know, one tiny thing is this has different wheels than Curiosity. So we figured out from Curiosity, okay, these wheels work, but they cause some problems when we're trying to climb hills. How do we fix that? We went away and we fixed it and we put different wheels on Perseverance. So we've learned from everything we've done over the past 50 years. As I've kind of mentioned, we're going to a place with a very high potential for finding signs of past microbial life, which will tell us a lot about what type of life previously existed on Mars, and it will tell us a lot about the changes that Mars has experienced over millions and billions of years. We're going to collect a lot of important data about the geology, so the rocks and the climate of Mars. And again, every robotic friend that we send over to Mars is doing one thing and one thing only. It's figuring out how we follow it up with some humans. So we're going to find out a lot about the climate and what potential impacts that may have on any astronauts that we send to Mars in the future. It's the first leg of a round trip to Mars. So again, this is going to be the first time we're ever going to try and achieve some rock samples and then actually go ahead and bring them back. And it carries instruments and technology that will pave the way for future human missions to the moon and to Mars. And again, the moon is really important in this, and we're going to end with a little bit of information about the moon that really gets me excited. But looking into ways of creating oxygen not only helps us figure out if humans will ever be able to breathe on the planet Mars, but oxygen is one of the biggest components of rocket fuel. So we want to figure out, can we make rocket fuel on the surface of Mars so that if we do send humans, you know, we can bring them back home. And finally, you're going to get to ride along, and so will I. One of the coolest things that I'm super excited about for this mission is there are 1 million names inscribed on a tiny little microchip that's embedded on Perseverance. And I signed up and I've got my ticket to Mars all set. Unfortunately, you can't do that now, but you can pre-sign up for our 2026 mission. And again, I'll give you all the links you need at the end. So that's really exciting. But even if you didn't get to do that, this is going to be the most interactive mission that NASA has ever operated. Like I said, we're sending 23 cameras to the planet's surface. There are going to be so many different ways to view this mission, the launch and everything. NASA does a really cool thing called NASA Social, where they invite certain people to watch the launch in person. They can't do that for this one for obvious reasons. So they're opening it up to so many more people, and they're going to create Facebook groups and all this kind of stuff that really helps you get involved and get excited about this launch. So I'm going to show you guys now just a 2-minute video on, like I said, my favorite piece of this mission. I want to introduce you all to Ingenuity. So I think my two favorite things are, number one, powered flight on another planet is insanely cool. And you can really see that in the faces, even though they were behind masks, of the scientists. You saw how excited they got just at simple things like being able to make that latch pop open. They got so excited that it works. And I encourage you to look a little bit more into that. There's a video available that I won't show you right now, but it shows you all the different problems they found. Like, they created this huge room and turned it into a vacuum to simulate the lack of atmosphere on the planet Mars. And you should see that helicopter fly away, because it is very difficult to control. But we think they figured it out, and it's pretty exciting. So Perseverance and Ingenuity both have names from contests from school-age kids. So if you've got a child, if you are in school right now and you're watching this, firstly, it might be past your bedtime. But secondly, there are so many different ways to get involved with NASA. And again, I'll make sure you guys get all the links you need at the very end. But one of my favorite things is Alex Mather from Springfield, Virginia. His quote, they had to write essays to be able to justify why their name deserved to get picked. And I was lucky enough to be part of the panel to judge some of those essays. And this one really just, it gives me goosebumps. We're always curious and seek opportunity. We have the spirit and insight to explore the moon, Mars, and beyond. But if rovers are to be the qualities of us as a race, we miss the most important thing: perseverance. And I think that's so true, and just so important to bear in mind that these missions are about so much more than just the science themselves. They really are about what brings us together as people. So Alex and Vanessa is the person who named Ingenuity, the helicopter. They took an opportunity just like any of you sitting at home right now could take to get involved with a NASA mission. So I'm going to wrap us up with talking a little bit about how we're actually going to get to Mars. So if you are watching this and you are in grade school, you are about the right age to be the first generation of people to land on Mars. And how are we going to get there? Well, we're going to get there by firstly going to the moon through what we call our Artemis program. And that's going to begin, the aim is to get boots on the moon for the first time in a long time. By 2024, we're aiming to get our astronauts, the first woman ever to get on the moon, by 2024. And one of the key things we're going to try and do is actually set up a space station that orbits the moon called Gateway. So one of my other favorite NASA topics is the International Space Station. I could deliver a whole other presentation about that, but we're going to try and replicate that at the moon, so we actually have a whole station available to us, because it's so much easier to launch to Mars from the moon because there's less gravity holding us back. And so we're going to try and create this Gateway space station at the moon so that we can more easily get there, restock, resupply, and hopefully build almost an actual working town on the moon. Like I said before, I'm the village planner for the village of Woodridge. I'm an urban planner, a town planner by career. And one of the things I said in my job interview is that they ask you what your dream is and what you want out of your career. And I'll tell you what I told them, which is I want to be the first town planner to plan a town in space. And with the Artemis program, we may very well actually get that opportunity. So I am going to end on one more very short 5-minute video. It's voiced by Kelly Marie Tran, who some of you may know as Rose from the most recent Star Wars trilogy. And it gives a great explanation about how we're going to actually get to the moon, and from the moon, get to Mars.
Between 1968 and 1972, America launched 9 human missions to the moon, 6 of which successfully touched down, allowing 12 men to walk on the lunar surface. NASA's next chapter of lunar exploration, called Artemis, has the task of not just going to the moon to create a long-term human presence on and around it, but also to prepare for ever more complex human missions to Mars. In short, everything we must be able to do here, we must first do here. So, what will an Artemis mission look like? Everything is designed and tested with our most important element in mind, the astronauts. This is their deep space, human-rated spacecraft called Orion, built in 3 parts. The crew module, where up to 4 astronauts will live and work throughout the flight. The service module, with life support systems for the crew and its own engine and fuel reserves. And a launch abort system, with engines capable of pulling the crew module to safety during launch should anything go wrong. To accomplish the task of launching our crew and heavy payloads, NASA is building the Space Launch System, comprising of a cargo hold, an exploration upper stage, a massive core stage, and 2 extended solid rocket boosters. Altogether, this is the world's most powerful rocket, and it exceeds the legendary Saturn V of the Apollo era in numerous ways. Sitting on the launch pad, the entire rocket, fully fueled, weighs just over 6 million pounds, 5.2 million of which is just the fuel. Once ignited, there is no stopping what comes next. All 4 RS-25 engines and the 2 solid rocket boosters come to life, thundering our crew upwards. 2 minutes after ignition, the solid rocket boosters are spent and released. 8 minutes after launch, the core stage is depleted and separated. The upper stage fires briefly, placing Orion into a parking orbit around the Earth. Here, the crew reconfigure the spacecraft and check systems to confirm everything is ready for deep space travel. With a go from mission control, the crew reignite the exploration upper stage engines to leave Earth entirely. The exact timing of this maneuver is critical to reach a speed that can escape Earth's gravitational pull, but also put Orion on a course that will intersect the Moon days later. Once this burn is complete, the upper stage of the SLS is jettisoned and the crew aboard Orion coast for several days toward all that awaits them at the Moon. Approaching the Moon, we see the fundamental differences between Artemis and Apollo. Instead of requiring Orion to serve as an expendable lunar command module or to carry a constrained lunar lander, the Artemis missions will take advantage of a different approach: pre-staging. Everything needed for lunar missions will be positioned in advance by commercial and international partners. This includes rovers, science experiments, and human-rated systems on the surface. But it also includes a dedicated lunar station in orbit around the Moon called Gateway. Here at this station, we can pre-stage a robust lunar lander and establish a strong communications relay. Designed with open standards, the Gateway can be expanded as new missions and partnerships develop, allowing multiple human missions on the Moon at the same time and enabling ongoing science to be conducted even between human missions. The Gateway is also capable of adjusting its orbit to allow access to every part of the Moon, something the Apollo missions could not do. But the real key in this approach is placing Gateway in a unique halo orbit to perfect the maneuvers needed for Mars missions. And with the growing list of commercial and international opportunities, Gateway is the ideal hub between Earth and all that lies beyond. Returning to our crew as they approach Gateway, the Orion must match the elliptical orbit of the station in order to successfully dock. Once on board, pre-selected crew members transfer to the lunar lander, while those assigned to Gateway remain on station. The lunar lander system itself is built for 3 unique steps: descending from the halo orbit of Gateway down to a low lunar orbit, descending from low lunar orbit to the surface, and once the lunar mission is complete, launching from the surface of the Moon and ascending all the way back to the orbiting Gateway. Once back aboard the Orion spacecraft and undocked from Gateway, the crew fire their engine once to break out of the halo orbit, and once again to sling the spacecraft around the Moon, placing it on a multi-day trajectory back towards Earth. As they near the end of this journey, the service module is released, and the crew module is oriented heat shield first. Entering Earth's atmosphere at 25,000 miles per hour, the friction of air slows Orion considerably, while also subjecting it to temperatures of 5,000 degrees. With the Orion now at just 300 miles per hour, a series of parachutes uniquely tested and produced for this moment deploy, decelerating the craft to just 20 miles per hour for splashdown. With each successful mission, Artemis ushers in the next wave of men and women to explore our Moon and prove that together we are ready to go beyond.
Alrighty, folks, that is us. So we are going to go to the Moon, and from the Moon we're going to go on to Mars. and we're gonna get the planet ready for us with all of our different rovers and landers and satellites and everything else. And pretty excited for, fingers crossed, July 30th for the launch of Perseverance. So just to give you guys a couple of little links, you can tweet me, I guess. I'm never on there, at failure to launch. Great pun. I have a website, philip-green.com, and I'm going to put a page on there with links to everything we talked about tonight. So you have a one-stop shop. And there's my email address for if you want to kind of email me any questions or any follow-up. That's fine. And I'll pop the link to my profile on the NASA website. You can contact me through that as well. Just in case there's anything that you want to speak to me about after the fact. You know, that's how I got into this, was emailing the guy that gave the talk last year and finding out more. So please do feel free to reach out to me. Thursday night, July 16th, Woodridge Library is having another virtual event, this time a little bit more scientific perhaps than what I gave tonight. And it's a chap from the Naperville Astronomical Association, and he's going to be giving a really interesting talk on the best stargazing sites you can discover from your backyard this summer. And it's great timing with the comet Neowise being visible to the naked eye right now. He'll be a great resource for you guys to find out a little bit more about stargazing and astronomy. And like I said, the Perseverance launch window starts July 30th. Hopefully I'll see you all back here right around February to hopefully see how the landing went. So thank you all so much for your attention tonight. I genuinely do really appreciate it. And I am happy to open it up to questions if anybody's got any. There should be a raise hand button available if anybody wants to use that, so I can know to call on you for a question. If not, the thumbs up works just as well, or the clap, and I can see you and unmute you, and we can ask a question. Let's see, I see one. Mr. George, I see you. Do you have a question?